Hello everyone. Here we are doing calculus problems. This is an example with infinite limits. So here we start with sketch the graph of y equals 1 over x squared. Let's just, before we do that, check out that if I put in x equals 0, the result is y equals 1 over 0 squared, which is undefined because 1 cannot be divided by 0. So that's leading us to that you can put any number in for x, but not 0. The domain is all real numbers except not 0, except for 0 for x. And what we're going to see is that leads to a vertical asymptote. The quick answer to the graph is that it looks like what I'm about to draw here. Let's check it out. Let's use pink. This is how it looks, something like this. And we have this vertical asymptote. Zoom out a little bit to make it even more, I don't know what. To emphasize that vertical asymptote, I'm going to zoom out. Okay, so something like that. That's a hand-drawn sketch, as you can see. It's not using a computer, but maybe it's not that bad either. So let's check it out. Why? If I plug in numbers, let's see what we got. This function is y equals 1 over x squared. Given, say, x is 1, what we can do is we can square 1 and then take the reciprocal. Get 1. 1 squared is 1. The reciprocal of that is 1. Here we put in 2. This gives 1 over 2 squared. So what we can do is square 2. 2 squared is 4. And then reciprocal, 1/4. Or 3. 3 squared is 9. Then reciprocal of 9 is 1/9. 4. 4 squared, 16. Reciprocal, 1 over 16. See all the things we can do without a calculator? It's amazing. Okay, but sort of falls off the graph pretty quickly anyway. What the result is, though, is x gets large, y gets very close to 0. On the other hand, as x gets small, meaning x close to 0, we see that the y gets large because we can square 1/2, get 1/4, reciprocal in 4. Or one way to look at it is you could reciprocal 1/2 and get 2, square that and get 4. 1/3 reciprocal 3, square 9. 1/4 reciprocal 4, square 16. So we see that, say at just a 1/2, when x is 1/2, y is already pretty steep. It's actually not really quite showing that here. It should be even steep. No, hold on. Yeah, no, if this is 1, yeah, so it should be even steeper at 1/2. But it's not that bad, this graph. Okay. So, all right, so this is 1. It's not really all that well done to scale, but it's not that bad either. All right, now the thing is, what would happen if I put in negative 1/4? Well, I could reciprocal, get -4, and square 16. So see, the negative squared makes positive 16. Put negative 1/3, reciprocal -3 squared, and you get 9. So putting in negatives give the exact same value for y. Same value for y. -4 squared is 16. Positive 16 squared, you get 116. So we get the same y values if I put the opposite values for x. So that's pretty something. Is it so great, amazing? I wouldn't call it that, but it's sort of, well, it's what we see here. The graph is symmetric around the y-axis, which makes it an even function, by the way, but let's not talk about that today. All right, I think that's enough for plotting points and showing that. Okay, so what we see is, let's just check it out. Now the question about this within infinite limits is this. So as as x approaches 0 from the right, so this means from the right of 0. Why am I saying this to the right of 0? Because of this little plus here. See, 0 is neither positive nor negative. It has this little plus. An arrow doesn't mean equal, by the way. It means x gets close to 0. X gets close to 0 from the right, and that's over here, right of 0. So from the right, x gets close to 0, and what we see is that the function keeps going up. The graph keeps going up, and so the function is getting larger and larger and larger without bound, which tells us it's not approaching a number. The y doesn't approach a number. It just gets larger without bound. So that what we write is we write infinity. Infinity is not a number, though. Infinity denotes that we can make 1 over x squared as large as possible. Then from the left is the question of the next problem. Left of 0. What do I mean? I mean I look at this vertical line, the y-axis. The y-axis is the line x equals 0. So I'm looking to the left of 0. How do I know that? Because I have this x arrow means approach 0, and this little dash or minus, whatever that is, means come from the left. And in the graph, it means I draw arrows along the curve going where the x coordinates are getting closer and closer to 0, but they're negative, and they just keep going up and up. Therefore, up and up means infinity. So these infinite limits, where it says the limit is infinity, the infinite limit's infinity, go hand in hand with the vertical asymptote. Now this final one, it says what's the limit as x approaches 0 without a plus or a minus, indicating that we're talking about both sides, whether we're going from both sides. Either way, do we get the same infinite limit? And the answer is yes, because from the left and the right, we both get infinity. So from both sides, infinity. State any vertical asymptotes. Yes, there's a vertical asymptote, which is the vertical line x equals 0. All vertical lines are expressed in the form x equals a number. So the y-axis is the line x equals 0. So that's just the way it goes. The y-axis is the line x equals 0. Alrighty. I'm not sure why I was using that weird pen that looks more like spray paint or something. It's not very clear at all, obviously. Okay, well, let's finish with a joke. Why do birds fly south for the winter? Because it's too far to walk. That's all. So take care, and isn't calculus super fun and amazing? Yes. Okay, take care. Bye.